Laplace transform. The next topic is the many applications are there of this Laplace transform. Then suppose the one important application, if you have ordinary differential equation and partial differential equation, sometimes if you want to solve homogeneous linear ordinary differential equation or partial differential equation, then we need to calculate complementary function and particular integral. After calculating this one, complementary function and particular integral, with the initial condition you have to calculate C1 and C2 or how many arbitrary constants are there, all those things you have to calculate it. After calculating we will get the solution. Means by using Laplace transform, no need to calculate complementary function and particular integral. Without calculating all these things, if you have differential equation with the initial conditions, then we will apply the Laplace transform on both sides. We will get the solution of the ordinary differential equation, partial differential equation. Then what is the definition? Means Laplace transform of, suppose the function is in terms of t, then you should remember one thing, the question is in terms of t and the answer is in terms of s. Every time the question will be in terms of t, then you will get the answer in terms of small s. This thing only, Laplace transform. Again here we have two parts actually. One is Laplace transform, other is inverse Laplace transform. Once you got Laplace transform, then automatically we can understand the inverse Laplace transform also. Now suppose f of t is piecewise continuous function, then Laplace transform of f of t is denoted and defined as L of f of t equal to integral 0 to infinity e power minus st f of t dt, where t is greater than or equal to 0, means t values lies in between 0 to infinity. T is greater than or equal to 0. Now this is the definition of the Laplace transform. And I used one word, f of t is piecewise continuous function. Piecewise continuous function means if you have one interval a comma b, then you take some sub-intervals of that given interval. In each and every interval, this f of t is continuous. The meaning of that one is, piecewise continuous is, in each sub-interval also, the f of t is continuous. Like that. This is nothing but piecewise continuous. And this Laplace transform of f of t, already I told you, integral 0 to infinity e power minus st f of t dt, it converges to some finite quantity. Then only Laplace transform exists, otherwise it does not exist. Converges to some finite quantity. This is the basic definition of the Laplace transform. And applications are, by using this Laplace transform, we will solve the differential equation, ordinary differential equation or partial differential equation, without calculating the complementary function and particular integral. Then by using this basic definition, how should I calculate the Laplace transform of some elementary functions? Elementary functions means if you have constant function, if you have some small functions, means in terms of polynomial, t square, t cube, this type of functions, exponential function, sine function, cos function, sine hyperbolic function, cos hyperbolic function, like this. I will explain you by using this integration how to calculate that one, and after that I will give the formulas directly. Now suppose Laplace transform of k, where k is constant, any real constant, then how should I calculate this one? Now we know that Laplace transform of f of t equal to integral 0 to infinity e power minus st f of t dt. F of t value is nothing but k. Laplace transform of k is nothing but constant. f of t equal to k, means you substitute in place of f of t k, that equal to integral 0 to infinity e power minus st into k dt. K is outside. Integral 0 to infinity e power minus st dt. Then k into integration of e power minus st is e power minus st by minus s. The limits are 0 to infinity. Upper limit is infinity, lower limit is 0. Then in place of t you substitute that infinity, e power minus s into infinity by minus s. Again minus e power minus 0 is 0. That is e power minus 0 is e power 0, that is 1. Then again divided by minus s is there. Then e power minus infinity value is directly 0. That direct formula, 1 by e power infinity, 1 by infinity is 0 directly. Therefore the answer is 1 by s. K is outside, is available. K into is there. Therefore the answer is Laplace transform of k equal to k by s. Means from this formula what should I understand? Laplace transform of 1 equal to 1 by s. Laplace transform of 2 equal to 2 by s. Laplace transform of 5 equal to 5 by s. Like that. Right? Now this is Laplace transform of constant function. In the same way, Laplace transform of e power at. E power at. Then what I will do here? Laplace transform of, again the formula f of t, Laplace transform of f of t equal to integral 0 to infinity e power minus st f of t dt. F of t dt. Then integral 0 to infinity e power minus st f of t in place of f of t e power at. Again that equal to integral 0 to infinity e power minus s plus a, otherwise a minus s into t. Minus s plus a into t. I have taken bases are same, add the powers. Then you do the integration. Integration of this function is with respect to t, e power minus s plus a divided by e power minus s plus a into t divided by minus s plus a. Then limits 0 to infinity. After applying limit, the answer is 1 by s minus a. 1 by s minus a. Then Laplace transform of e power at equal to 1 by s minus a. In the same way, Laplace transform of t equal to, in place of f of t, you substitute t, then integration by parts, we will get the answer 1 factorial by s square. In the same way, Laplace transform of t power n equal to, what is that, n factorial by s power n plus 1. N factorial by s power n plus 1. Again we have the formula here. This instead of n factorial we are writing in another way, gamma n plus 1 by s power n plus 1. Then this is very very important. Actually Laplace transform of t power n, where n is greater than 0. Here n, where n is some numbers greater than 0, then gamma n plus 1 by s power n plus 1. Then how should I calculate? Why should I use this formula? Suppose t square is there. T square means 2 factorial by s cube formula. The formula is n factorial by s power n plus 1. T power n is available, that n value is suppose purely integer, then we can calculate it very easily. Means positive integer, then we can calculate it. Suppose if it is fraction part, it means 1 by 2, n in place of n equal to 1 by 2, 3 by 2, 5 by 2, minus 1 by 2, minus 3 by 2, then you should use the formula gamma n plus 1 by s power n plus 1. Then we need to understand gamma function. The gamma n equal to, the formula is integral 0 to infinity e power minus t power n minus 1 into dt. This is the basic definition of the gamma function. And gamma n plus 1 equal to n into gamma n. that can be written as gamma n plus 1 equal to n into gamma n, that equal to n factorial. Already we have taken, instead of n factorial, I have taken gamma n plus 1. Then this formula, if the power of n is positive fraction or plus p by q form, means gamma 1 by 2. Here one important, very important notation, gamma 1 by 2 is square root of pi. This you have to remember. Gamma half equal to square root of pi. Everywhere if you observe gamma half, simply you write there square root of pi. Means positive fraction is there, gamma 3 by 2. Suppose I will explain you gamma 3 by 2. How should I calculate this one? Gamma 3 by 2 is gamma half plus 1. Gamma n plus 1, already I am using the formula n gamma n, means gamma half plus 1 means half into gamma half, square root of pi by 2. This is gamma 3 by 2 value. Similarly, we can calculate gamma 5 by 2. Gamma 5 by 2 can be written as gamma 3 by 2 plus 1. Gamma 3 by 2 plus 1 means 3 by 2 gamma 3 by 2. Gamma 3 by 2, that is nothing but gamma 3 by 2, already I have calculated square root of pi by 2, and 3 by 2 is there, 3 by 4 gamma 3 by 4 square root of pi, like that. Suppose under gamma, if t power n is there, t power minus half, if you observe minus half minus 3 by 2, then how should I calculate? Then already we have gamma n plus 1 equal to n into gamma n. Gamma n plus 1 equal to n into gamma n. That gamma n can be written as gamma n plus 1 by n. This formula is very important for the positive fraction. Like this you have to calculate it. What is gamma minus half? Then you substitute here, gamma minus half equal to under gamma minus half plus 1 by minus half. Then that can be written as minus 2 into gamma half, minus 2 into square root of pi. Like this we can calculate the negative fraction of gamma function, like this. Now you can use this gamma function, is very important while solving the Laplace transform problems. Sometimes the t power, if it is positive number, then we can calculate n factorial. Once again, t power n is positive number, means t square, t cube, t power 4, n factorial by s power n plus 1. Suppose instead of positive number, if you have plus half, 3 by 2, 5 by 2, minus half, minus 3 by 2, negative fraction, then specially you have to use the formula gamma n plus 1 by s power n plus 1. Now, and all these formulas I have given in one table very easily, and some important trigonometric formulas also I have given to you. Then using that table you can solve each and every problem. Right. Now this is the basic definitions of the Laplace transform. Then some more, what are the important properties of the Laplace transform, I will explain you.